Okay, we're going to solve some, or work with some exponential equations in Algebra 1. And specifically, if you look at your formula sheets on the Georgia Algebra 1 EOC formula sheet here, you can see, maybe kind of small on your screen, but your exponential equation y equals a times b raised to the x. So we're going to use that on this sheet here, do a couple problems. So y equals a times b raised to the x. So looking at this first question, ask you to write an exponential growth function to model each situation, then find the value of the function after the given amount of time. Annual sales for a fast food restaurant are $650,000 and increasing at a rate of 4% per year. Okay, so on my board here, I wrote down that equation that we saw in the formula sheet, and in this situation, you have $650,000. So what you start with. When you do an exponential equation, which can be, you can identify by this appearance, it has a variable in the exponent. The number in the front, which is this a value, is always what you start with, or what you currently have. So in this case, it's going to be $650,000. And you need to know that the a value is what you start with. Now here in Algebra 1, we're not going to worry too much about you coming up with a b value on your own. Certainly you would in Algebra 2. If you look back at it, it says it's increasing by a rate of 4% per year. Okay, that's going to be 1.04. Okay, now this is going to be your model. The reason it's 1.04, this represents 104% of what you had originally. So at year 0, 1.04 raised to the 0 power would be just 1. 1 times 650,000 is just 650,000. But at year 1, you're going to multiply 650,000 times 1.04. That's taking 104% of it, which makes it a larger number. And if you put a 2 here, you're going to multiply it by 1.04 twice. You're going to take 4% more the second year, and then for the third year, you do 4% of that larger number. But long story short, if you just know that the number in front represents your original value and that your percentage is going to show up in here, that'll be fine for this particular worksheet. Now, this is the model, which is, the model just means you have all the variables filled in except for x and y. To actually answer the question, you're going to need a calculator for sure. And we're just going to fill in 5 where x is. Now, a lot of times you'll see a t there where that is. All right, so let's go ahead and put this into Desmos then. And we'll see what we get. So 650,000. You can use graphing or scientific here. It doesn't matter. 650,000. Sure, get enough zeros in there. Raised to the 5th power. Okay, so you can see, I'm going to write it on my board here and show you in a minute. $790,824.39. Okay. Now the reason we do 2 decimal places is because of money. All right, you're not going to, there's no reason to just put money out here forever, because our smallest amount of currency is a penny. So I cut it off there at 39 cents. Make sure your answer is reasonable. Of course, it should be bigger than 650,000 with an interest rate of, or rather a growth here of only 4%. It's not going to be tremendously more than that. So if you get a number that's way up in the billions or something, you know something's wrong. If you went backwards and got smaller, you know something's wrong, etc. So be wary of that. I'm going to skip down this worksheet to number 7. Now it says in the instruction, if you'll notice, exponential decay. And again, that's more of an Algebra 2 topic. But for now, we know that it's going down in value. So I have a population of town of 2,500, and you're decreasing at 3% per year. Okay, so again, back to our equation. 2,500. Now this time you're decreasing, so you're not really responsible for coming up with this B value. You may be curious as to how to do it. Well, if you do nothing, then it's going to be 100%. Well, since you're going down 3 percentage points, it's going to be 97%. Okay, again, you're going to raise that to a power. Okay, so if you're going down, the number is less than 100, 0.97 in this case. It says to find the value after 5 years. Okay, so we're losing people. I expect it to go down. I don't expect it to go way down because 3% is not a lot, but I do expect it to go down. I'll put a 5 in there. I go to Desmos. Race to Shift 6 here is the quickest way to do it, or you can go down here and do that A over B button if you want to the 5th power, right? After 5 years. Okay, so you can see it's down to 2,147. And notice this time, we think about it in context. We are talking about people, so you don't want a fraction of a person. That wouldn't make good sense. So for that reason, I wrote 2147 would be the best answer for this one. I want to conclude with looking at these interest problems. Okay, if you'll notice on our formula sheet, you have this compound interest is written kind of small there. But you have this compound interest formula right there. Okay, and this is another example of an exponential because as an exponent, they can vary. But the P here, right there, is the principal, which is the amount that you have up front. Your R is your interest rate. N and T often get confused. N is the number of times you compound interest in a single year, and T is the number of years. So we're going to use this worksheet here to show an example of that. Actually, back here on number 4. Okay, and you can see that someone has $50,000 and then invest at a rate of 3% compounded monthly. It wants to know how much money will they have in 6 years. Okay, so I'm going to write down that formula. It's always a good idea to write down your formulas to start with because it provides a template. Okay, this is straight off that sheet I showed you. And you're not going to have to memorize it. You'll be allowed to use the formula sheet on the EOC. But we have this. In our situation, it was $50,000 invested at 3%. So let's go and get those in. A is just the amount after a certain number of years. We'll get to that in a minute. But the same concept as before. Whatever you start with or whatever you currently have goes in the very front. This is the number 1. Your interest rate here again is 3%. So 3% would be 0.03. Okay. Remember, percent literally means multiply by 100. Divide by 100. I said that wrong. Per 100. Okay, so 3 divided by 100 would be 0.03. Move your decimal place 2 positions to the left there. Now it says compounded monthly for 6 years. The adverb monthly determines your value of N. How many months are in a year? Well, there are 12 months in a year. I'm going to put that here and here. And for 6 years. T, the amount of years only goes in there one time. Okay. Now you're going to see some different words for N. You may see annually, which is once per year. N would equal 1. Semi-annually, which is twice a year. N would equal 2. Quarterly, which is 4 times a year. N would equal 4. Those are some other common ones. But the most common is monthly, which is what we have here. Okay. So we're going to apply this. We're going to see what Desmos tells us, and remember, we should get a number larger than 50,000, but not incredibly more than 50,000, or something's wrong with our figuring here. So I'm type in 50,000, 1 plus 0.03 divided by 12. A little trick in Desmos, again, Shift 6 If you just say 12 times 6, notice that it kicks the 6 out of the exponent. You get a number that's way too big. This 309,000 right here, way too big. There's no way you're going to have that much money. So what we want to do instead is put a parenthesis right here, and that helps hold the value in the exponent. So you're going to end up with 59,847. Remember what I told you here, 2 decimal places, so 42 cents would be your final answer there. So that's compound interest.